And so this is truing stand on a wheel. It's like pretty basic. People always ask if we have the machine that trues wheels, but there isn't a machine, it's me.
So here's the manual bicycle wheel truing stand. You can see we have the wheel mounted in it by the axle, so it's free to spin. And over here is a set of calipers that comes in contact with the rim. And you can hear, whenever it's in contact, the calipers scrape, and then intermittently they'll come off whenever the wheel's untrue.
In order to fix this problem, one must take a spoke wrench and tighten and loosen particular spokes to pull the rim in line with the hub. One repeatedly does this until the wheel is in true.
Manual bicycle wheel truing is a slow, tedious process, so I came up with an idea to automate it, and to do it in a more precise manner.
Thus, trueWheel was born. trueWheel automates this tedious process using a custom-designed stand, algorithm, and sensing system to properly align each spoke. Let's begin with the stand and sensors. As you can see here, we have potentiometers mounted in the lateral and axial directions. The potentiometers will come in contact with the rim and record the position of the rim relative to the hub position. This determines the misalignment with the hub. There will be a motor attached to the hub that spins the wheel, taking continuous data. In order to determine where each spoke of the wheel is, we will attach an IR beam to the stand. When the spoke crosses that IR beam, the computer will recognize it as a spoke, and this will allow us to match any deflection point to a specific spoke.
Our device utilizes a MATLAB code that takes the sensing data from the potentiometers and IR beam and outputs spoke turning instructions. The sensing data measures the position of the rim at each spoke. After defining the zero position in both directions, our problem becomes one big math problem. Spoke turning is calculated by first finding the distance needed to put the wheel in true for each spoke. Our code converts this distance into a number of revolutions needed, determined by the thread pitch in the nipple and the axial loading of the steel spokes. The magnitude of the force due to axial loading is determined by an FEA of a sample wheel modeled in SolidWorks.
Wow, Kristen, it looks like wheel truing just got a whole lot easier.
Yeah, and as we move into the future, we look to automate all aspects of the wheel truing process and make it as accurate as possible. We truly wheel that with the support of our viewers, trueWheel will be a great success.
Hakuna Matata, what a wonderful phrase. Hakuna Matata.